Hi guys, welcome back to my YouTube channel. My name is Venon Insofa, and in today's video, we're going to talk about the regulation of beta oxidation. As always, please don't forget to subscribe and also don't forget to comment. If you haven't watched my other video, please go and watch my first video on beta oxidation and then come back to this one. So in this video, we're going to focus on the regulation of beta oxidation only. So what regulates beta oxidation? That should be the first question. So before we go on the regulation part, first of all, we need to revise. When does beta oxidation take place? So beta oxidation takes place when we are starving, during prolonged starvation. But it can also take place in diabetic patients because these people, their cells are unable to uptake glucose. So beta oxidation can occur in those individuals. And the purpose of beta oxidation is simply to produce acetyl-CoA. And that acetyl-CoA, it is utilized in TCA cycle to produce ATP. Now, in beta oxidation, we talked about this very important enzyme, which we call carnitine acyltransferase 1. It is also known as carnitine palmitoyl transferase 1. What was the purpose of this enzyme? So this enzyme is the one that converts acyl-CoA to acylcarnitine. But why are we converting acyl-CoA to acylcarnitine? The mitochondria has two membranes. It has got the outer mitochondrial membrane and the inner mitochondrial membrane. The outer mitochondrial membrane is permeable to acyl-CoA or to fat acids. But the inner mitochondrial membrane, this one is the one that is stubborn because it is impermeable to acyl-CoA. Therefore, if we want to transport acyl-CoA into the mitochondria, we must first convert it to acylcarnitine because acylcarnitine can cross the inner mitochondrial membrane and enter mitochondria. So the purpose of this enzyme was converting acyl-CoA to acylcarnitine because we want to transport acyl-CoA into the mitochondria. So for us to transport it, we must convert it to acylcarnitine, then acylcarnitine will enter the mitochondria. So this enzyme is very important. And remember, I said that this enzyme is known as carnitine acyltransferase 1, or you can call it carnitine palmitoyl transferase 1. Now, when we are breaking down fat acids, it means that we don't have glucose, or glucose cannot enter into the cells. And when you look at fat acid synthesis, making of fat acids, they are made from acetyl-CoA, which comes from glucose. So when you don't have enough glucose in the body or in cells, cells cannot make fat acids. And when you look at fat acid synthesis pathway, the building block for fat acids is a molecule that we call malonyl-CoA. Now, the interesting part is that when we're building fat acids, or when we're making malonyl-CoA is made from acetyl-CoA, and that acetyl-CoA comes from glucose. So for us to convert acetyl-CoA to malonyl-CoA, there's an enzyme that we call acetyl-CoA carboxylase, and that enzyme is activated by insulin. So in short, insulin activates the formation of malonyl-CoA, and malonyl-CoA is made during well-fed state. So during well-fed state, we are going to have malonyl-CoA. But what's the importance of malonyl-CoA? Malonyl-CoA, it is an inhibitor of this enzyme, carnitine acyltransferase 1. So during well-fed state, you're going to have a lot of malonyl-CoA and you're going to be making fat acids. Therefore, you're going to inhibit the breakdown of fat acids because it cannot make sense you're making fat acids and then you're breaking down fat acids. It's like someone is building a house and then another person is demolishing the same house. It's a total waste of energy. So the body, it is made in such a way that when we are building fat acids using malonyl-CoA, this same malonyl-CoA is going to inhibit carnitine acyltransferase 1. When we inhibit carnitine acyltransferase 1, we cannot make acylcarnitine, and therefore we cannot transport acyl-CoA into the mitochondria. So During warfare state, when you have got glucose in the body, you're going to produce insulin, and insulin will stimulate the formation of mononuclear. In other words, the level of mononuclear is going to increase. And mononuclear is an inhibitor for this enzyme because we don't want to have fatty acid synthesis and beta oxidation at the same time. Now, when a person is starving, when we don't have glucose, you're going to find that the alpha cells will start producing glucagon. So the alpha cells, these are cells that are found in the pancreas. They'll produce a glucagon. And the glucagon, what happens is that it prevents the formation of mononuclear, so that you shouldn't be making fat acids because you want to use that acetyl-CoA to make ATP. So instead of using that acetyl-CoA to make mononuclear, you should use it to make ATP. So glucagon will inhibit the production of mononuclear from acetyl-CoA. Now, eventually, the level of mononuclear will drop. And when there is less mononuclear in the cell, it means that there is nothing to inhibit carnitine acyltransferase 1 enzyme. Therefore, carnitine acyltransferase 1 enzyme is going to be activated because there is no mononuclear. So when you're starving, glucagon will be produced and it will inhibit the production of mononuclear. And when there's no mononuclear, there's nothing to inhibit this enzyme. Therefore, this enzyme will become active and it will convert acyl-CoA to acylcarnitine, which will enter the mitochondria and for beta oxidation. So, in summary, we can say that during warfare state, the body produces insulin, and insulin activates the production of mononuclear. Mononuclear, it is an inhibitor of carnitine acyltransferase 1, which is also known as carnitine palmitoyltransferase 1. When this enzyme is inhibited, you cannot convert acyl-CoA to acylcarnitine. Without that, you cannot transport acyl-CoA into the mitochondria for beta oxidation. The overall effect is inhibiting beta oxidation. That's how we inhibit beta oxidation. Now, how do we activate beta oxidation? Beta oxidation is activated when we don't have mononuclear, and that is during starvation. So during starvation, your body produces glucagon, which will inhibit the production of mononuclear. And without mononuclear, there's nothing to inhibit carnitine acyltransferase 1 enzyme. Therefore, if there's nothing to inhibit this enzyme, it will become active. And when it is active, it's going to be converting acyl-CoA to acylcarnitine, and acylcarnitine will enter mitochondria, and then beta oxidation will be activated. So this is all I got for you in a nutshell. See you in the next video.